are now going to start with the topic on stoichiometry. Because yesterday I found that most of the students are able to write the formulas properly. Electronic configuration you all understood well. So that made me feel that, well, I should directly go for these things. Okay. And you will find that each and everything which is taught in the school will be different from what I'm going to teach you today as far as all these topics are concerned. Stoichiometry. What does it deal with? It deals with measurements. Measurement of what? Stoichiometry. This topic deals with measuring or calculating or determining the amounts of reactants required to prepare or to obtain a certain amount of product, or it could be dealing with the amount of product formed from a given amount of the reactant. Suppose Abdul Salam is there and Jasima is there or Akshit is there. You all want to prepare some important new substance. And you know the starting material. Let us say carbon dioxide. You want carbon dioxide. Or let us not say carbon dioxide, say oxygen is required. Can you all tell me what is the substance from where we normally prepare oxygen? Can anyone tell me? What is that starting material which can be used to prepare oxygen gas? KClO3.
Oxygen atoms.
Huh? KClO3. What is KClO3? Potassium chlorate. Potassium chlorate. On heating will give KCl and O2. So supposing I want some amount of oxygen, I have to find out how much of this KClO3 is required to obtain this oxygen gas. So in stoichiometry, we are going to deal with these topics. But to do this, there are certain basics which have to be done. Rakshit, Jasima. Jasima, I'm not able to hear anything from you. I don't know you're there attending the class or not attending the class. Are you there in the classroom or not? I don't know. I request the Math IIT person to please check up whether Rakshit is writing, I mean not Rakshit, Jasima is doing work or not. Rakshit, I want your camera on, Rakshit. Yes, yeah, that's better. Jasima, I would like your camera to be on because I want to see what the students are doing. And I'm very particular about this part. Let me tell you, it is not that we are doing online for the first time nowadays. Before even Zoom came, there was a platform which was called a Cisco platform, or there was another platform which was called as VizIQ platform. Since 2009, I have been into this part. So I normally know what the students are doing. I observe the students very carefully, and I want my students to be attending the class with sincerity. Jasima, I want your camera on, or at least your microphone on. Now, anyway, did you understand what I'm saying? In stoichiometry, we are going to do this part. This chapter of stoichiometry is divided into the following segments. What are those following segments? The following segments are, number one, write down, laws of chemical combinations. After laws of chemical combinations, there is another one which is going to be called as mole concept. From mole concept, we go to chemical calculations. From chemical calculations, we will be going to expressing concentrations of solutions. From expressing concentrations of solutions, we go for mixing two different solutions and finding the resultant strength. For example, a very crude example, नींबू पानी बनाते हैं. Nimbu pani, if we can have, or you can say the lemon water which gets there, I can make a concentrated one. And that concentrated one, day by day, I can use and dilute it and do it. So when I'm diluting, am I mixing two substances or not? That is the lemon water, concentrated, plus adding water to it. Adding water to lemon soda or lemon water. What is it going to be called? Can you name it? Milk is there, you add water. Sugar cane is there, juice is there, you add water. You have got even lemon water, to that you add water. What is that going to be called as?
Dilution.
Adding water.
Dilution.
Name. Yes, exactly. Dilution. Very good. Dilution. Dilution problems are there. Then afterwards, again, using concentration of solutions, finding again chemical calculations. So you can understand. These are the 7 subtopics which are there under this heading of stoichiometry. And in our NCERT textbook, this is called as some basic concepts in chemistry. And normally in school, many schools, they just do only this part and leave it. But we do have this part also and these parts also. Then what happens when we don't do it in 11th class, just because for the want of time when the teachers don't do it, what happens is this particular portion becomes a problem in class 12 syllabus. So that is why I am very particular that all the students should be doing these parts properly. Will you or not? Coming to laws of chemical combination. Now our real course starts. Laws of chemical combinations. The different laws of chemical calculations are, laws of chemical combinations are, right now, I don't want this part. The different laws are, number 1, law of conservation of mass. Law of conservation of mass. 1 minute, students. Something went off over here. I don't know why that particular slide is not coming. The different laws are: number one, laws of chemical combinations के अंदर law of conservation of mass, then law of constant proportion, law of constant proportion. Just a moment, students. Just a moment. Just a moment. One minute. Now the slide came. These are the different laws. What are they? Law of conservation of mass, law of definite proportion, law of multiple proportion, Gay-Lussac's law, Avogadro's law, and one more is there in between. One more, a very important one, which is what is also called as law of reciprocal proportion. Law of reciprocal proportion. Students, 1 minute. Something happened to my PPT. Law of reciprocal proportion. Have you written them? On number one, law of conservation of mass, law of constant proportion, law of multiple proportion, law of reciprocal proportion, Gay-Lussac's law, and Avogadro's law. And Avogadro's law. Written. Written, students. Now, first one, the law of conservation of mass. Write down. It states that matter can neither be created nor be destroyed by any physical nor chemical means. By any physical nor chemical means. This is called as law of conservation of mass or matter. Either you call it as matter or you call it as mass over here, nothing wrong. You can replace this, even right here, even mass. Mass can neither be created or matter can neither be created nor destroyed by any physical nor chemical means. ठीक है? अब मैं एग्जाम्पल देता हूं. Right now, there is a H tube. There is a H tube. Please draw this. For the board examinations, you have to draw like this one. H tube. Inside the H tube, there are two columns. A column and B column. There are two columns. Okay. I close them. And in one column over here, I take H2SO4. I have taken here H2SO4. And in the other part, over here, I take up magnesium piece. Magnesium piece. I close it. What am I doing? I'm closing both the ends. It is closed. What is this part, students, called? What is this one? What is this one? What is this part? Dilute?
Dilute
H2SO. And what is here?
Magnesium piece.
I weigh it. I weigh it. Now the weight will be what? Weight of H tube plus magnesium plus sulfuric acid I find it is equal to W grams. Now I tilt it. And I say here that this whole of magnesium which is there, this whole of magnesium which is there, it goes here. When it goes here, reaction will take place. What will happen then? What will happen? Can anyone tell me? Reaction will take place or not? Yes, reaction will take place.
Yeah, MgSO4 and
and you get magnesium sulfate.
yes, and hydrogen.
And hydrogen gas.
And hydrogen gas. No, hydrogen gas will be inside this or not? Yes, hydrogen gas will be trapped inside it. Let me say that the whole hydrogen gas is filled over here. It is filled over here. And it is filled over here. And I find here that this part is not there because magnesium got dissolved completely. Magnesium got dissolved. And therefore here I have magnesium sulfate. Here I have magnesium sulfate. Now, whatever magnesium was there, that will get converted to magnesium sulfate or not? Answer. I'm not getting your answers. Whatever magnesium was there, that will get converted to magnesium sulfate? Yes, or from somewhere some magnesium will come?
No, that magnesium will convert to magnesium sulfate.
Whatever magnesium was there, that got converted. Therefore, what will be happening here? This also will be equal to W grams. What is this called? Reactant. And what is this part called? Magnesium sulfate plus hydrogen gas. That is called as product. Okay. And what will happen? I find here weight of H tube plus weight of H tube plus magnesium sulfate plus hydrogen equal to W grams. So this means mass of the products is equal to mass of the reactants or not? Mass of the product is equal to mass of the reactants. Right? Did you understand? Yes or no? अब ये कैसे? मैंने एक इक्वेशन लिख दिया यार. मैग्नीशियम लिख दिया, सल्फ्यूरिक एसिड लिख दिया, और मैंने लिख दिया मैग्नीशियम सल्फेट plus hydrogen gas. Whatever hydrogen is present in H2SO4, that will get converted to hydrogen. How much soever magnesium was there and how much soever sulfate was there, those two will combine to form magnesium sulfate. Please note down. Please try to understand what I'm saying, students, because that's important for your examinations later on. Whatever jitna hydrogen hai, वो पूरा का पूरा सल्फ्यूरिक एसिड के अंदर जितना हाइड्रोजन है, that gets converted to hydrogen gas. Whatever is the sulfate and magnesium present, that gets converted to magnesium sulfate. Okay. Done? Have you all drawn it? Drawn it or not? Drawn or not?
Yes,
Okay.
sir.
Next. I don't want this part, students. I want to say something else. 1 minute. I don't want this part. Yeah. Please see here. I have got over here Na2SO4. And in this, I have taken calcium nitrate. It reacts. Now what happens? All of them are inside only. So what will be happening here? You will get calcium sulfate plus sodium nitrate. And water will be there. The mass of calcium sulfate plus sodium nitrate will be equal to mass of sodium sulfate plus calcium nitrate taken in the beginning. Okay. फायदा क्या ये पढ़ने का? What is the use of studying all these things? Neha. Can you put on a camera, Neha? What is the use of studying all these things? I want my students to put on the camera, please. What is the use of studying these things? Is there any use? See here now. I'm going to tell you the uses. Right now. What is the chemical equation? What is the chemical equation, students?
Symbolic representation of a chemical reaction.
Yes, please write it down. Please write. A chemical reaction. Chemical equation is a symbolic representation of a chemical reaction. Okay. Now, I'm giving you an equation. Please listen carefully. Don't be in a hurry to answer anything. Sodium sulfate reacts with barium chloride to form barium sulfate plus sodium chloride. Okay. It is a chemical reaction, and I want to write the equation for it. What is the formula for sodium sulfate?
Na2SO.
Na2SO4.
Na2SO4. Good. What is the formula for barium chloride?
BaCl2.
What's the formula for barium sulfate?
BaSO.
What's the formula for sodium chloride?
NaCl.
NaCl. Is that clear? Have I represented the symbolic representation or not? Have I done the symbolic representation or not? Yes, I have done the symbolic representation. Now, all of you, please listen to this part. I'm giving sodium atomic weight as 23, sulfur atomic weight as 32, oxygen 16, barium equal to 132, and chlorine 635.5. Find out now the mass of the reactants here. 46 plus 96, 132 plus 132 plus, what is it? 71 132 plus 96. Okay.
23
And
plus
sodium
35.
chloride. Please write down. Sodium chloride 23 plus 35.5. Sorry, I made a wrong mistake, students here. It is 137, please. 137. 137. Make it now. What is here the mass of the reactant? 46 plus 96 equal to how much? 142. Here how much? 3. 203. Here 233.
Sir,
And here
137 now. Then it will be 208.
pardon?
Sir,
Yeah,
BACL
137. That's it. 137. 208.
208.
Right. 58.5. Now tell me what is the mass here? And what is the mass here? Total mass. 0, 5, and 3.
350.
And here, how much?
So 350.
1, 9. Is mass of the reactant is equal to mass of the product?
No, sir.
No, sir.
That means our chemical equation is not obeying the law of conservation of mass. Whether you balance or not, will the law of conservation of mass be followed or not followed? आपने बैलेंस नहीं किया, बैलेंसिंग को छोड़ दो, आपने एक्सपेरिमेंट किया, तो मास ऑफ द रिएक्टेंट मास ऑफ द प्रोडक्ट के बराबर होगा या नहीं होगा रिएक्शन करते समय? Yes, it will be there. But मेरा representation क्या कर रहा है? My representation over here is against the law of conservation of mass. But symbolically, I have represented them correctly or not? Yes, I have represented them correctly. Why are the mass of the reactants not equal to mass of the products? Because I have not balanced. So what is the use of law of conservation of mass? Yes. What is the use of law of conservation of mass?
So it helps us to recognize how much product has been formed.
Okay, that is one part. That is one part. Something else also. Something else also.
To make
It
sure
says that our representation should be balanced. Then only it is correct. Otherwise, it is wrong. Why do we balance chemical equations? Because our equation should be obeying the law of conservation of mass. Because in an experiment, it is obeyed. So our representation also should be following it. Therefore, we balance chemical equations. Abdul, did you understand, Abdul?
Yes, sir.
What is the meaning? Did you understand? Why are we balancing chemical equations? Chemical equations must be balanced because otherwise we will not be obeying the law of conservation of mass. Our representation should obey the law of conservation of mass. That is why we balance equations.
yes, sir.
Neha, Prithviraj, Rehan, Rakshit, I hope you all understanding. Neha,
Yes, sir.
I'm not able to see, I'm not able to hear anything from you. Muhammad Fad, Prithviraj, I want you people to answer. So, now tell me, Ayush, what is the use of law of conservation of mass?
So that we can know how to balance it and
Not how to balance. How to balance different. We must balance the equation. That is the use. Nothing else. Okay? Nothing else. We will talk about balancing afterwards, after a few days, when I do oxidation number and other things. Then, as of now, no. Did you understand this part? Now,
Yes,
next.
sir. Yes.
Let us go for some equations, some questions on this part. Do this question. All of you do this question. Done? Now here, it is not a question of doing. It is a question of how we present for the board examinations or school examinations. I must say, the day since the IIT people or anybody has brought this particular MCQs part, every student has lost his capacity to express their answers. Previously, when I used to correct the papers, every student used to compete about the representation, presentation, etc. Nowadays, nobody is doing it. The students should know how to present. याद रखना, examiner से marks छीनना पड़ता है. You have to extract the marks from it. So our presentation should be good. See here, how do I do? What mass of sodium chloride would be decomposed by 9.8 grams of sulfuric acid if 12 grams of sodium bisulfate and 2.75 grams of hydrogen chloride is produced? First point. This is the reaction. Don't bother about balancing and other things at this moment. I'm not doing that part. Most important. According to law of conservation of mass, total mass of the reactant should be equal to total mass of products. This is how you should write. According to law of conservation of mass, total mass of the reactant should be equal to total mass of product. Now, mass of reactants. Let mass of sodium chloride decompose be x grams. So, mass of the reactant is equal to x plus 9.8 is equal to 12 plus 2.75. So you can write one more point over here. And what is that? You should write over here that mass of sodium chloride NaCl plus H2SO4 equal to mass of NaHSO4 plus NaCl. That is what we should write. Not NaCl, sorry. HCl. This is HCl. So mass of NaCl how much? X. Mass of H2SO4 9.8. Mass of NaHSO4 12. Mass of hydrogen chloride 2.75. Therefore, from here, we then write X is equal to this much. Nothing here. X plus 9.8 is equal to 14.75. Therefore, X equal to 14.75 minus 9.8, which is equal to 4.95. This is there in your textbook. Don't worry, these questions are there in your class 11 book. Done. I hope all of you have done.
Yes, sir.
Can I go to the next question? Delete. Can I go to the next part?
Yes, sir.
Yes, sir.
Prithviraj, Mohammad Fad, Rehan. I want to answer.
Yes, sir.
Next. Do this question. do this question. Give you 2 minutes time. Presentation is very important for me.
So what should we finding here?
Yeah?
So what should we finding
Yeah.
here?
Is this data obeying the law of conservation of mass or not?
Okay, sir.
Is this data obeying the law of conservation of mass or not? Good. Ayush, you read the question properly because I was waiting. Anybody who will ask me, because I didn't write the question part of it purposely, to check up whether the students are reading the questions carefully or not. Yes? I want to see whether the students are doing or not. So I would like to check up. Please show your camera and I would like to check up these. Abdul Salam is not there.
Sir. Hello.
Okay. Prithviraj, camera on. Rehan, Mohammed Safat, please open the camera. I would like to see whether you're right, whether you're doing the question or not. Yes? Anybody who has done, show me on the camera. Past students. Rehan, क्या बात है यार? दिखाओगे नहीं क्या? Prithviraj, good. Prithviraj, can you just show me the? Is it possible for you to show me on the camera, Prithviraj, what you're doing?
So just 1 minute. I'm not.
Pardon?
I'm still doing it. Once I'm done, I'll show you.
Okay. Ayush,
Yes, sir.
show.
Okay.
Little more nearer to the camera. No, it's not so clear anyway. 1 minute. 1 minute, 1 minute, 1 minute, 1 minute, 1 minute. I'll zoom it out. नहीं यार, थोड़ा और पॉइंट्स मिस कर रहे हो तुम. लिखने का तरीका ऐसा होना चाहिए. Total mass before the chemical change. Mass of AgNO3 plus mass of NaCl plus mass of water. अब इस क्वेश्चन के अंदर 2 बार mass of water आया कि नहीं? 2 times mass of water has come or not? Mass of water here 100
Yes,
for silver nitrate. Then mass of water here for what? Sodium chloride. So what will be the answer? Here 1.7 plus 0.58 plus 200 grams. Answer equal to how much? 202.285. Now mass of the products will be how much? Mass of silver chloride, mass of NaNO3 plus mass of water, because water will remain. Did I give you that value of mass of water again? No, but that is understood to be there. 1.435 plus 0.585, sorry, 0.85 plus 200. Answer 202.25. This is how the representation should be. Hence, thus in this chemical change, total mass of the reactants equal to total mass of the products. Therefore, law of conservation of mass obeyed. इस तरीके से होना चाहिए प्रेजेंटेशन. Done? The next law. I'm finding here that slowly and slowly the students, they are joining, going out. That shouldn't be the case. Are you all understanding or not? Rakshit, understanding?
Yes, sir.
Sure. Next. I go to the next law, which is called as the law of definite proportion, or called law of constant proportion. It is also called as law of constant proportion. You can write this. I will give you a definition, which is much more important. And that is the way it should be done. This is only to understand a given compound always contains exactly the same proportion of elements by weight or by atoms. You can write and include over here, or by atoms. Slash or by. Students, स्कूल के अंदर और कहीं पर भी टीचर्स क्या करते हैं, फॉर्मूला पहले लिखते हैं, फिर रेशियो निकालते हैं. ये नहीं है. इसका एक्चुअल डेफिनेशन क्या है ये लिखिएगा. व्हाट इज द डेफिनेशन? Whenever elements combine, they do so in a fixed proportion by mass or by write down. From here only chemical formulas were determined. Please write down. From here chemical formulas were determined. But school में क्या करते हैं, सब जगह पे क्या करते हैं, केमिकल फॉर्मूला लिख देते हैं, फिर कहते हैं कि रेशियो बाय मास, रेशियो बाय एटम्स। गलत है। कैसे पढ़ना चाहिए वो पढ़िएगा आप यहां पर, राइट नाउ। सपोज करो हाइड्रोजन का एटॉमिक मास है 1U, ऑक्सीजन का 16U, कार्बन का 12U, सल्फर का 32U। U का मतलब यूनिफाइड मास, U इज इक्वल टू यूनिफाइड मास। जब मैं स्टूडेंट था उसको कहते थे AMU, एटॉमिक मास यूनिट्स। बाद में जब मैं टीचर बना पहली बार फर्स्ट ईयर एज अ टीचर, ये रिड्यूस हुआ MU, मतलब मास यूनिट। आफ्टर 10 years of me becoming teacher, it is nowadays called as U, called as unified mass. Atomic mass unit, अब कह दिया है unified mass. This is the one which we take nowadays, unified mass. It is a unit. Unified mass is a unit of atomic mass. One unified mass equal to 1.66 into 10 to the power minus 24 grams. Liquid students. One unified mass is equal to 1.66 into 10 to the power minus 24 grams. But I'm not going to do any conversion at this moment to grams. Okay? I will just say parts. Unified mass, I'm going to call now as mass. Sorry, parts. Yes, you can, Rakshit. Okay? Unified mass, now I will say as parts. Supposing Ayush is there. Ayush, he performs a chemical reaction. And what does he do? He takes hydrogen and makes it combine with oxygen. And Ayush found that 500 parts of hydrogen require 4,000 parts of oxygen. He did this perform the experiment. Next. Abdul, he performed the experiment in his place. Abdul says that 200 parts of hydrogen combined with 1,600 parts of oxygen to form same compound. Now, Prithviraj says, well, why do you want to prepare like this here? I already have that particular compound in my home. He says, he takes the compound from his home. Prithviraj takes the compound and finds that 10 parts of hydrogen combined with 80 parts of oxygen. Now let us talk about Ayush. H is to O by mass. 500 is to 4,000. What is the ratio by mass?
1:8.
1:8.
Abdul performed the reaction and he finds 200 is to 1600. Again he finds same 1:8. Prithviraj says 10 is to 8, 80. Again 1:8. That means ratio by mass, same for all of them or different for all of them?
Same.
Write down. If compound is same, ratio by mass will be same. This is what was observed by the scientists initially. They didn't give any formula at that time. They just performed and then found that the properties of the compound was same and the ratio by mass was also same. Write it down. Written. Now, what is atomic weight? Write down. Weight of an atom of an element. What is atomic weight? Weight of an atom of an element. That is atomic weight. Weight of an atom of an element. Now, 1 U of H means how many atoms of H? Atomic weight of hydrogen is 1. So 1 U of H means how many atoms of H?
1.66 into 10 raised to minus 20.
No. How many atoms I'm saying? Not saying grams.
So
Atomic weight,
1.
weight of an atom of an element, I said. So what is it? One
One.
atom of hydrogen. How many of you understood this? 16 U of O means how many atoms of oxygen? 1 atom of oxygen. Now my experiment, what is it saying? Experiment says, in all the cases, H is to O is 1:8 by mass. That means 1 U of hydrogen is combining with 8 U of oxygen. This is combination with elements in a fixed proportion by mass. Now, let us try to write down the ratio by atoms, number of atoms. 1 U of H means how many atoms of hydrogen? 1 U of H means how many atoms of hydrogen? On the board it is written. 1 U of hydrogen means how many atoms of hydrogen?
1 atom.
1 atom. So I can write here 1 atom of hydrogen. Now, 16 U of oxygen is equal to 1 atom of oxygen. So 8 U of oxygen is equal to how many atoms of oxygen?
Half.
Half.
That is 8 by 16. There is nothing but 1 by 2 atoms. 1 by 2 atoms. Can half an atom exist?
No.
No.
So I can multiply both sides by 2. If I multiply both sides by 2, it becomes what? 2:1. Multiply both sides by 2. Why am I multiplying? Because fraction of atoms cannot exist. 1 atom can be there, 2 atom can be there. 2.5 atom cannot be there. Okay. Now, therefore, H is how many atoms? 2. Oxygen is how many atoms? 1. Therefore, what is the compound? H2O. This is how the chemical formula came up. That is how they derived the chemical formula. Later on now, we are using the valencies, etc. Is that clear? So, we are going to do in our next class some more questions on this part. And then I'll tell you In the school, how will they expect you to answer? That is more important beyond marks. So how are they going to ask us the questions and how are we going to answer? That we'll do in the next class. How many of you understood? How many of you understood? Good. Rakshit has not understood. Prithviraj has not understood.
Sir, I understood, sir.
Okay, please put the hand.
Yes, sir. Even I understood, sir.
Okay, all of you understood. Fine. Then in that case, we stop the class over here and let us see for the next class. Maybe tomorrow or whenever. Okay, fine. Thank you.
Thank you, sir.
Yes, sir.